Good evening. My name is VN Nafuka and I'm a member of Group 3. Before I proceed with my presentation, I would like to express my sincere apology for not being able to participate in the recording presentation and for the absence during the submission process on YouTube. My absence was due to unforeseen circumstances beyond my control. I was also assigned a part to present during the group work, and I regret not being able to contribute on that day. I trust my apology will be accepted and I appreciate your understanding. This presentation will address the requirement analysis for, for providing electricity to a remote village. The following categories that have been identified. Those are the inputs, the outputs, the functions, environmental issues, packaging issues, structural issues, safety issues, as well as maintenance issues. The inputs. This is what you will need to run the system. You've got the energy sources. We will run the village on a solar power. The chosen solar panels can produce up to 5 hours of daily energy with specification optimized for best efficiency, total capacity of 500 kilowatts. Extra power generated will be stored by batteries, 3 megawatt hour of capacity as a backup to feed during night hours and cloudy weather. We also use backup fuels for standby generators if the solar panels are not working. We also have infrastructure materials such as transformers, the 500 kVA, 33 to 11 kV, and a 50 kVA, 11 kV to 400 volts. Batteries, inverters, cables, and poles with a protective cabinet that is rated at IP65 for weather resistance. We also have at least a team of 2 local operators that will be trained. The community uplifting data of 150 households and a maximum population of 950. And the daily energy needed is about 2,500 kilowatts hour. Our outputs, the system is designed to outputs of 230 volt AC and the frequency of 50 Hertz of higher quality, which is appropriate for the community use. The system needs to be equipped with a peak power of 600 kilowatts and should have a reliability of 95%. In total, it will provide for a daily energy provision of a small community which consists of houses, a school, a clinic, as well as the community borehole and a church. Functions. What does the system need to do? The system needs to generate and save power. For the solar panel, you can use 24 hours per day. Need to supply and distribute electricity through a mini grid to the houses, school, clinic, community boreholes, and church. Need to control the voltage and currents to avoid overloading and ensure safety. And with usage and fault reporting and maintenance alert. The environmental issues. Environmental sustainability is a priority. The system is designed to reduce emissions and noise, avoid negative impact on ecosystem of the region, use sustainable materials to minimize carbon footprint, and the IP65 rating for durability against the environmental and weather. The packaging issues. Physical protection is paramount, particularly in remote areas. Enclosure will be weatherproof, rated IP65, and secure from rain, deaths, and animals. The devices will be portable for quick installation and accessible to maintenance so that repair can be made without disrupting with the community. Structural issues. The structural consideration includes foundation stability. We will make sure the support structure are strong enough to withstand local and weather conditions, ensure conductors and poles are as per anticipated electricity load, and the system will also have a growth plan for future expansion as the community grows. Safety issues. Safety is paramount. Correct earthing, installation, and protective devices will be in place for electrical safety. Higher or medium voltage equipment will be labeled and fenced for public safety to prevent accidents. We are going to train local people in how to respond to hazards. We plan for all equipment and to comply with electrical safety and standards that will protect both people and the environment. Maintenance issue. Ongoing maintenance to be considered. Routine inspection will be performed for wears, tears, or damage. Spare parts such as batteries, fuses, circuit breakers, poles, and conductors will be available. We will introduce PMS sensors and communicate the defects on lines, proper training to local personnel on basic maintenance. In conclusion, that is the end of my presentation on requirement analysis for our project to provide electricity to a remote village. And I thank you.